All right, so we're starting off with this polar curve r of theta equals 3 theta plus sine theta from 0 to 2 pi. And we want to find the area in the second quadrant. And this is a calculator question, so you could go in and graph this and see what it looks like. But if we're specifically talking second quadrant, we should know that we need to do our integral from pi over 2 to pi. So we'll do 1/2 of an integral from pi over 2 to pi of our r value squared, but you can just write r of theta if you want, or if you want to write 3 theta. I prefer to write 3 theta plus sine theta squared. Don't forget to write the d theta, and make sure you're in radians on your calculator and just plug that into your calculator and get an answer. And you should have got 47.513. And that one was, amazingly, for how easy it was, worth 3 points. 1 point for having the correct integrand, 1 point for having the right limits and the right constant out in front. Could have had the constant inside also, and then 1 point for actually evaluating and getting the right answer. That's an easy 3 points for part A there. Anybody have any questions on that one? Okay. Part B, I think, should have also been fairly straightforward. It says that there was 1 point on our polar curve with an x-coordinate of -3 in the second quadrant. And we want to find the angle and the y-coordinate of that point. So if the x-coordinate is -3, we can just say that -3 is equal to our r value times cosine theta, because that's what x is r cosine theta. And no need in any way to try and solve that on your own. You can just use your calculator to do that and have your calculator tell you that the theta value you get is 2.01692. I feel like that's pretty straightforward there. So there's the first answer that you were supposed to get. And so far, this was 2 points, 1 for correctly writing that equation, 1 for getting that theta value. And then the third point for this one was for finding the y-coordinate. And I mean, that should also be pretty straightforward. We know that y is equal to 3 theta plus sine theta times sine theta. And y equals r sine theta. We'll just evaluate that at theta equals 2.01692. And that gave you a value of 6.272 for the y-coordinate. And that was the third point. Everybody good there with part B?
Yes.
All right. Somebody has written something in the chat. Yes. Nick has written yes. 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 Good. Wonderful. Oh. All right. And then the last part of this one, part C. What did part C even say here? We got a particle traveling along the curve. Its position is x of t, y of t. And d theta dt is 2. We want to find dy dt when theta equals 2 pi over 3. And so in order to do that, we're going to need to use the y-coordinate. And so our y-coordinate, as we said a minute ago, was 3 theta plus sine theta times sine theta. So y equals 3 theta plus sine theta times sine theta. And if we are looking for dy dt, that means we need to take the derivative of this side with respect to t also, which means we'll take the derivative of it with respect to theta first. So that ought to be 3 theta plus sine theta times cosine theta plus 3 plus cosine theta times sine theta. that's dy d theta times d theta dt, which I believe is what they gave us. And so we're just going to evaluate all of this at theta equals 2 pi over 3. And you can use your calculator to do that if you wish, or you can not use the calculator if you also wish. But it came out to be negative 2.819. And I think it asked us something like, explain what that means in the context of the problem. So all that means is that the, this is dy dt, so that's how y is changing with respect to time. So it just means that the y coordinate, the value, maybe we say the value of the y coordinate is decreasing at a rate of 2.819 units per time period. I don't know if it gave us a time period, so it didn't. Yeah, just decreasing at a rate of 2.819 would be good enough. And that one was also worth 3 points. So 3 points, 1 for correctly applying implicit differentiation of the chain rule there, 1 for getting 2.819, and 1 for saying that the y coordinates value is decreasing at 2.819. Good or no?
Yes.
Wonderful. Oh, somebody's written something in the chat again. Fun. Yes, that one was fun. I agree. Cool. All right, let's see. This one was one I said I would just answer questions on if anybody had any questions on it. Anybody have any questions on this one? Since we're going through, I just feel like now is the time to ask questions on this one if you had any. I got one. No, this one was really easy. Everyone's good on this one? Sure. You can see part C real quick. Sorry, 1 second. I had to do something real quick. My dog. Okay, sorry about that. Thought she was bleeding all over again, but it was just a little bit. So good news. All right. Okay, you said part C, is that right? Part C? Okay. Oh, somebody else says. Okay, yes. Okay. So part C asks us, well, it says there's a point P on this graph, the graph of F, which the line tangent to the graph of F is perpendicular to the graph of G. And so if it's going to be perpendicular to G, that means we need to find out what the slope of a line that's perpendicular to G is. So G has a slope of -1. So perpendicular to G ought to be, I'll say the slope perpendicular to G ought to be a +1. So we're just looking for when does the tangent line to F have a slope of 1. And so the tangent line to F is got a slope of F prime. F prime of X equals 1/2 root X. And we just need to set that equal to 1 and just solve for x. So it looks like we multiply by root x and then square it, we should get x equals 1/4. And it wants the coordinates of it. So if x is 1/4, square root of 1/4 is 1/2. That's all it was. Good? Everybody good there? Yep. And I don't know, I did pull up the scoring guideline for this one. So my best guess is they probably gave you 1 point for, I remember I did this one with AB a few days ago. I think they gave you 1 point for this, 1 point for setting up the equation, and 1 point for the final coordinates on that one. I think it was 3 points for part soothing. Okay. Let's take a look at this one. This was one of the ones that I asked you guys to do, right? Yeah. So we got the function f of x equals e to the 2x. We got this region R bounded by f and a vertical line, and we know that k is greater than 0, blah, 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 blah. All right, so we want to write but not evaluate an expression with an integral that gives the perimeter of R in terms of k. Well, first off, this piece should be easy. That piece is just 1. This piece should be easy. That piece should just be k. This piece is easy. That piece should just be e to the 2k. So the rest of it is this nice curved little piece from e to the 2x, which means for that piece we have to use the arc length formula. So we're going to use an arc length formula for that. So our expression for the perimeter, we'll say the perimeter is equal to 1 plus k plus e to the 2k plus, then it should be an integral from 0 to k. And then our arc length formula is the square root of 1 plus the derivative of our function squared. And so the derivative of e to the 2x is 2e to the 2x squared dx. And that's it. And they said they give a specific point for writing what f prime is. So try to write out what f prime is off to the side. F prime is 2e to the 2x. But I think if you had it in there, that's probably good enough because it doesn't specifically say what is f prime, but good to demonstrate why you're putting 2e to the 2x in there. And they gave 3 points for that one. 1 for the value of f prime, 1 for the correct integral, and 1 for the whole thing. Everybody good there with part A? All right. Part B then tells us that we've got the region is rotated around the x-axis to form a solid. We want to find the volume, so if we're going to rotate that around the x-axis, that's going to give us disks, which should have an area of pi times the radius, which is just our function squared. And we're just going to still do this all in terms of k. And so we should be able to start off with our volume is equal to pi times the integral from 0 to k of our radius of e to the 2x squared dx, and e to the 2x is just e to the 4x. And if we integrate e to the 4x, we should get 1/4. So that's going to give us a pi over 4 out in front. So pi over 4 e to the 4x from 0 to k, which is going to give us pi over 4 times e to the 4k minus 1. If you want to distribute your pi over 4 through, that's fine, but that's Everybody good with that? 1 point for having the correct setup for the integrand, 1 point for having the right limits and constant there, 1 point for correctly getting this antiderivative, and 1 point for evaluating from 0 to k. Any issues there? All right, and part C, we've said the volume that we found in part B changes as k changes, obviously. If the change in k, dk dt, is equal to 1/3, we want to determine dv dt when v is 1/2. So we should just be able to go back to our formula that we had here. And I mean, this is our volume formula, right? So if, let's see here, let's see. If our volume was, I'm just going to write it this way, pi over 4 e to the 4k minus pi over 4, then dv dt, derivative of that ought to be the derivative of this, which ought to just be pi e to the 4k. That's not a 4. Let's try that again. 4k times, and then it should be times dk dt, because we're taking the derivative of something where the variable is k with respect to t, so just the chain rule. And then plug in your things. So I don't remember what they were now. dv dt is what we're looking for. dk dt was 1/3 and k was 1/2. So we'll say dv dt equals pi e to the 4 times 1/2, and dk dt was 1/3, and so that should be pi e squared over 3. And that one was only worth what, 2 points. 1 if you did the implicit differentiation, taking the derivative with respect to t correctly, and 1 for getting pi e squared over 3. Oh, somebody said something here in the chat. Good. Oh, good. Yes, that was from a couple minutes ago. All right, everybody all right with that part?
Yes.
Wonderful. All right, let's see here. I think this was one that I just said do that one on your own if you felt like it, right? Anybody have any questions on this one? Not going to go through the whole thing because it's pretty straightforward when I think overall, but I mean, unless somebody wants me to. Oh, this one was a calculator question, I think, actually. Did you guys find exact values on this? Could have, but would have been a pain. I think they gave this one as a calculator question. No questions on that one? Okay. And then this one also was a pretty straightforward A-B type question. Any questions on that one? No, Nick says no. Everyone's good there on that one too? All right. Okay, now we got the baker. We're creating a birthday cake. Hooray! Somebody's birthday. All right, so we got the region R. It's cut out of a 30 by 20 centimeter rectangular sheet of cardboard. What a delicious cake made out of cardboard. And we discard the remaining cardboard. We want to find the area of the discarded cardboard. So first off, our area there should be, and we're given a function for this, right? So our area ought to be the entire thing, which is 30 by 20, minus whatever the area of region R is. So region R should just be an integral 0 to 30 of that function that they gave us, which is 20 sine pi x over 30 dx. And since this is a calculator question, just let your calculator do the work for you there. 600 minus that integral came out to be 218.028 centimeters squared. Good or no? They actually somehow gave you 3 points for that. They gave you 2 points for having the right integral and 1 point for getting the right answer. Like, super generous there. If I was making the AP test, I'd give you like a quarter of a point for that question. I don't know what a lowercase o with a hyphen next to it means, Darius.
I have like a small O. There's like a stutter. So.
Oh, I see. It's like oh, like you felt good because you got it right, but now I've crushed that. Is that what that meant?
No, it was about the being generous part.
Oh, I see. Okay. All right. Now our cake is a solid with a base of R, and cross sections of the cake perpendicular to the x-axis are semicircles, and the baker is going to use 0.05 of a gram of unsweetened chocolate for each cubic centimeter of cake. How many grams will be in the cake? Oh my goodness, what an exciting question. Get this. Those of you that want to be a baker, you can use calculus to determine your costs. How fun and exciting. So first off, we'll find an expression for the volume. So if we've got, what did it say we had? I forgot. I got too distracted by the chocolate. Semicircles, right? So we got semicircles that are perpendicular to the x-axis, which means that the area of each of the cross sections should be 1/2 pi times the radius squared. But if we think about our radius is, this is the diameter. So our radius is half of the value of our function. So our radius ought to be 10 sine pi x over 30. And so we will say that our volume should be an integral from 0 to 30. Was it 30 or was it 20? No, I can't remember which one was which. 30. Oh, good. Okay. An integral from 0 to 30 of 1/2 of pi times our radius, which was 10 sine pi x over 30, I think, squared. Or you could just write the full f of x over 2 if you wanted to. Dx, so that gives you the number of cubic whatever it was, centimeters. And that was 2,356.194 centimeters cubed for our integral. And then we want to know what that is times 500. And so if you multiply those out, looks like you get 117.810 grams of unsweetened chocolate. And so 2 points for the right setup with the integral, 1 point for the final answer. Good or no? All right, and then lastly, we want to find the perimeter of the base of the cake. Well, the bottom of it here, or it's not the bottom, but it's just this edge of it from 0 to 30 ought to just be 30. And then we'll use the arc length formula for the rest of it. So part C should be 30 plus the integral from 0 to 30 of the square root of 1 plus f prime. And they gave us what f prime of x was for this already. F prime of x squared dx, and you just plug it into your calculator and get 81.803 centimeters. 1 point for the final answer and 2 points for the correct arc length setup. So you should really be hoping for a nice, easy area volume arc length question, because the arc length ones, they seem to give you lots of nice, easy points on. And they gave you the derivative. Lucky you. So. Any other questions there on that one? Good. All right. I'll take that as a no. All right. So now we've got this fun looking little spiral thing here. So first thing it asks is for us to write an integral expression for the area of region S. We got a polar curve r equals 1 minus 2 cosine theta, and hold on 1 second. Sorry. Hold on, I gotta help my kid with something real quick. Okay, sorry about that. Okay, so we got r equals 1 minus 2 cosine theta from 0 to pi. And we got S is the region in the third quadrant. And so we want to write an integral expression for that area. So that should be fairly straightforward. We've got to figure out what our limits of integration here are for it. So if we plug in 0, if we plug in 0 to this thing, we're going to end up getting 1 minus 2 cosine 0, which is 1 minus 2, or negative 1. So this is where we're starting. So this is theta equals 0, right? It's got a negative r value. And then we're coming around here till we hit the origin. So we're starting at 0. So it should be 1/2 the integral from 0 to something of our r squared d theta. And we just need to figure out what that is. So that should be easy enough to do. Just take 1 minus 2 cosine theta set it equal to 0, give you cosine theta equals 1/2, and that happens when theta is pi over 3. So there is our expression. Didn't ask to evaluate, so that is good enough. They gave 1 point for the limits in the constant and 1 point for the correct stuff in the integrand. Good or no? All right. Oh, great. All right. So part B asks us to write expressions for dx d theta and dy d theta. So we know that x is r cosine theta. And what was r? It was 1 minus 2 cosine theta. Is that right? So y will be 1 minus 2 cosine theta sine theta. So dx d theta ought to just be the derivative of this, which is 1 minus 2 cosine theta times negative sine theta plus cosine theta times 2 sine theta. That's dx d theta. And dy d theta ought to be 1 minus 2 cosine theta times cosine theta plus sine theta times 2 sine theta. So that's that. You can distribute stuff through if you wish, but that's just up to you. Everybody good with that part?
Yes.
Cool. And if you looked at the scoring guide, like if you search for the scoring guide for this one, and you looked at the scoring guide, you'll see that they wrote out what dr d theta is. And remember, like way back when we did these derivatives of polar stuff, I was like, well, you can memorize these formulas, or you can just memorize x is r cosine theta, y is r sine theta. They just use the memorized formulas of like relating dr d theta to cosine theta and dr d theta times sine theta to get each one. So that's, it looks a little different, but this would get you all 4 points. That one was worth 4 points. So let's see here. Part C wants us to write an equation in terms of x and y for the line tangent to the polar curve at the point where theta equals pi over 2. Okay, so we need a slope, which means we need a dy dx at pi over 2, which means we're going to take our dy d theta at pi over 2 and divide it by our dx d theta at pi over 2. And cosine of pi over 2 is 0, so that term goes away and that term goes away. So that just leaves us with sine of pi over 2, which is 1 times 2, so we got a 2. And then down here we got a negative 1 times 1, which is just negative 1. So we end up with negative 2 as our slope. And then we needed the coordinates of the points. So x ought to equal 1 minus 2 cosine pi over 2 times cosine pi over 2 which, as we just said, cosine pi over 2 is 0, so that's 0. And y equals 1 minus 2 cosine pi over 2 times sine pi over 2. Sine pi over 2 is 1. Cosine pi over 2 is 0. So this is 1 minus 0 times 1, which is just 1. So our coordinates are 0, 1. And this should just be y equals negative 2x plus 1 if we write it in slope-intercept form. Everybody good with that? You got 1 point for getting 0 and 1. That was 1 point. You got 1 point for getting the slope and 1 point for getting the final equation. Any questions on that one?
Can you re-explain part A, please?
Part A? Yeah. So part A, it's just 1/2 r squared d theta, right? So that's how you find the area anytime in polar coordinates. But we have to find the theta values that give us region S. And the theta values that give us region S, we start at theta equals 0. Because at theta equals 0, that'd be going this way, but we get an r value of -1, which starts us here. And then we move in this direction of this spiral going out. And it's not a spiral, it's a lemma, so it's going to curve back around and give us another one of these. But it's going to give us a little inner loop. But the half that they gave us looks like a spiral. And so it's going this direction. And so we just found where it hit the pole again. So when our r value is equal to 0, so we just set r equal to 0 and solved and got that was at pi over 3. So this extends from theta equals 0 to theta equals pi over 3.
Okay, thank you.
Yep. Everybody good with that now? I'll take that as a yes. All right. So we're definitely going to be ready for the quiz on Monday. I was going to put another one up here, but give me 1 second here. Can't seem to find the one I wanted. That wasn't it either. There we go. I found the one I wanted. All right. So I'll give you guys 15 minutes to work through this one, then we'll talk about it. And then you guys can all see that, yeah? Perfect. All right, 15 minutes, and then we will talk about this one after that. And then I will post up a few more for you to work through this weekend as well. So 15 minutes starting now. So part A should have been pretty straightforward. Part A just wants the area of R. So the area of R ought to be the integral from 0 to k of that function, which is 1 over x plus 2. Integral of 1 over x plus 2 is natural log absolute value x plus 2, which we'll evaluate from 0 to k, which gives us natural log. And since we know that k is positive, we can just get rid of our absolute value, natural log of k plus 2 minus natural log 2. So part A, hopefully pretty easy. 1 point for correctly setting up the integral, 1 point for getting the answer. You had to do the anti-differentiation correctly to get the correct answer. It specifically says anti-differentiation and evaluation. So if you didn't put absolute value on that, they may not have given you the full point. So make sure you put the absolute value, even though it becomes insignificant for the values you're plugging in. So everybody good there with A? Hopefully so. All right, part B was, I would say, just about as easy. Find the volume if we take R and rotate it around the x-axis. We're going to do it again in terms of k. So it should just be pi times our integral from 0 to k of 1 over x plus 2 squared dx. And that's just a u substitution, right? This is really just u to the negative 2 with u equal to x plus 2, because if u is x plus 2, du is just dx. So that ought to become negative pi over u, so negative pi over x plus 2, evaluated from 0 to k, which should have been negative pi over k plus 2 minus pi over 2. Oh, sorry, minus, yeah, pi over 2. Everybody, sorry, minus negative pi over 2, so plus pi over 2. I can do arithmetic, yeah, plus. Minus a negative makes it plus. Negative pi over k plus 2 plus pi over 2. And this one, like I say, I'm going to give 3 points for this one. 1 if you have the right limits, 1 for the correct setup, and 1 for the anti-differentiation and evaluation. So 5 points total from A and B. Good or no? Okay. Then for the part that is where we had to know some actual like BC stuff here. So part C was asking us to take the region S, that's the unbounded region, the first quadrant, right of this vertical line x equals k. We want to find all values of k such that the volume of the solid generated when we revolve S around the x-axis is equal to the volume of the solid we got in part B. Let me see here, Adrian. You said for part C, if we noticed the total area of the regions R and S was pi over 2, would you have lost points for not setting up the integral? Let me think about that. How exactly did you, so you just said that the whole thing was pi over 2, and so you said that it needed to be that negative, right, half was pi over 4, so you just said that you just needed to make it negative pi over 4, and no, I think that's fine. I think that's not how they listed it out in the scoring guide. But if you, yeah, I mean, that would be perfectly acceptable to say that the entire area using, as long as you used an improper integral to find that area, and then took half of it and set this equal to it, that should be fine. Shouldn't be an issue with that. Yeah, I think you would have been fine. They always give other options for ways to go about doing the problem. So we'll do it since we're running out of time. So we'll do it the way they did it, and then we can demonstrate how you did it also real quick, Adrian. So first off, to find the volume of region S, volume of region S should be an integral from k to infinity, pi times the integral from k to infinity of 1 over that x plus 2 squared dx, which we just did that integral, right? Except we need to rewrite this now as a limit is, I don't know, whatever variable you want. The limit is a approaches infinity of the integral from k to a of 1 over x plus 2 squared dx. And that becomes the limit is a approaches infinity. And we already said that was, I forgot my pi, of, now, what was it? Negative pi over k plus, or negative pi over x plus 2, right? Evaluated from k to a. So negative pi over a plus 2 plus pi over k plus 2. And as a goes towards infinity, this piece here goes towards 0. So it's just negative pi, I keep doing a negative there, positive pi over k plus 2. And so we would then say, when does pi over k plus 2 equal whatever we got in part B, which was negative pi over k plus 2 plus pi over 2. So that'd be 2 pi over k plus 2 equals pi over 2. And you can forget about your pi's if you want, doesn't really matter. We need 2 over something to be 1 over 2, so that means k needs to equal 2. So that would have gotten you all 4 points for sure. So 1 point for having the correct improper integral set up, doing this and the limit. 1 point for correctly anti-differentiating and finding the value over here. And then 1 point for setting up this equation, and 1 point for getting k equals 2. And so what Adrian is saying is that he did it. He said that sorry, let me see what Jerry said. When it says all values of k, yeah, no, just 1 is good enough. Just because it says all values could be 1 value. All right, so Adrian said he did it this way. He said the limit is a approaches infinity of the integral from 0 to of 1 over x plus 2 squared dx, which gave you the limit is a approaches infinity. I keep forgetting my pi, of negative pi over a plus 2 plus pi over 2, and found that the total area was pi over 2. He said that then that means that each piece of it has to be half of it. So he said that'd be pi over 4 needs to equal 2 pi over k plus 2, not 2 pi over k plus 2, but it needs to equal, what was our value? Negative pi over k plus 2 plus pi over 2. That's what it was. Negative pi over k plus 2 plus pi over 2. Subtract the pi over 2 gives you negative pi over 4 equals negative pi over k plus 2. And you can again see that k equals 2. And so I'm pretty positive they would have given you the points if you'd done it that way as well. It doesn't say that in the scoring guide, but there's absolutely nothing wrong with doing it that way. So I would, for me grading it, I would totally give you those points. Any other questions on that one?